Second, you need oxygen. Okay? And then you need the bacteria. What are the bacteria to make vinegar? Acetobacteria and gluconobacteria. Those are the two major general names to making the vinegar. What is the product? Acidic acids. What is the percentage of acidic acids? 5 to 12%. Most of the commercial products is 5%. So if you see very simple, you buy any of the vinegar, when you look at the label, it is about 5 to 7% of the acidic acids. Okay? So we want to talk about this a little bit in detail. First of all, we want to talk about this acidic acids. Okay, what is acidic acid looks like? Acidic acids, if you want to say, this is called acetonic acids. What is acetone means? 2 carbon. What is nic means? Carboxy acids. So originally, it looks like this. This is originally looks like. Then what happened? Carboxy acid attacking this one becomes COOH. Therefore, it becomes acidic acids. And there is a 2 types of the writing, C2H4O2. However, this one we're not going to know the information very well. Therefore, we're writing CHCOOH. There's a carboxy base there. That is what the acidic acids. Okay, just give you some basic information. You may be learned in your chemistry class, maybe forgot. That's acidic acids. Now the second question, how the chemical reaction or biochemistry reaction behind the vinegar creation. So we want to talk about it a little bit more. Since we are in the food chemistry class. Okay, everything coming from this wine. We want to go back to talk about this starch. Okay, what is that? C6H10O5N. Starch, we know using amylase becomes what? A simple sugar. O6. This is a simple sugar. Most of the time glucose. Okay, then you have this guy. Going through a fermentation, you have a yeast called heterofermentation. Generate what? C2H5OH. Add CO2. This is the one we learned. Generate wine or even beer. Is that right? That's why you have a bubble, carbon dioxide. This is alcohol. Okay, then goes for alcohol go down. What is going to happen? First of all, they will be generate acetaldehyde. This is rely on most of the time. It's called alcohol dehydrogenase. Remove proton. Generate acetaldehyde. This is the one, if we want to talk about chemistry, NAD plus reduced to NADH2 has 3 ATPs generated. Remember, this is need oxygen. So it's an oxidized environment. You need oxygen, okay? Acetaldehyde, at the end of the day, will become acetic acids. We know about this. But how about in the middle? What's going to happen? They first will be reactive, become CHOH2. This is a hydrodase, and then with water. Okay? So what is this product called? Acetaldehyde hydrate. It's an intermediate product. Some people don't notice it. Then the directly goes here, become acetic acids. This last one is enzyme is acetaldehyde dehydrogenase. Then generate acetic acids. Now, this process, we also had NAD plus reduced to NADH2. How many ATP? 3 ATPs. Because of course this is with oxygen. Therefore, from alcohol, secondary fermented become acetic acids. Total is 3 add 3 equals 6 ATPs. Remember, if we do not do heterofermentation, we do homofermentation, how many ATPs generate? Only 2, is that right? If they generate lactic acid. That 2 coming from glycolysis, if you still remember. So that's why we want to talk a little bit more about the chemistry behind that. Alcohol, acetic acids, acetaldehyde, and acetaldehyde hydrate is a very short-term intermediate. Okay, we finished the talk about here. Tim, can you move this a little bit? Then we want to talk about something more. Okay, just move here around. Thank you very much. Okay, I will be using this area, okay? Now the question is how we manufacture the vinegar. So that's called the manufacturing vinegar. This we have a lot to talk. Okay, we were using different color we want to talk about. Basically, there is 3 methods. Number 1 is a very old method, slow fermented orange methods. Okay, what is orange method looks like? I'm going to give you a very wood barrier. A large wood barrier like this. Okay, this is a wood barrier. Now, of course, you need something there. There is some vial. This will be your product. 5 to 12% acetic acids. Okay, we have something we want to measure. This beaker, usually 500 liters. You're not going to fill everything. Fill around 60 to 70%. So 200 to 300 liters. Okay, this is going to be the wine is inside. Now where are you going to add? of course I need a channel. Okay, not really a channel, just a small pipe goes inside. You need a wine there. Now how are you going to add the bacteria? Bacteria you have to add from here. So bacteria usually floated on the surface. That's bacteria. Of course, what are they? Acetobacteria, gluconobacteria. They floated on the surface. Put the wine there. We need oxygen, is that right? How we do oxygen? You're going to dig a cup of hole there. A circle, 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 circle. These, you need to make sure there is a filtered meshing. You're not going to just dig a hole there, a big window. You need to make a mesh one. Why? We want oxygen coming. We need to prevent pets, rats, or some dusts. These don't like it. Don't tell me there is a fermented vinegar. At the end of the day, you find there's a rats there. They're not good. Okay? So this fermentation process took about at least 7 days, a week, at least. Now, how many products are you going to generate? Approximately 10 to 15 liter vinegar. Now, inside of this one, how many do you have? 60 to 70 liter wine, 15, around 10 to 15 liter vinegar. And this you have to refresh it. Okay, so every time we have vinegar kicking out, you're going to put a new wine there. That you have to do. So let's continue to do very slow. And take a longer time to do the fermentation for at least 7-10 days. So this is older methods, the orange methods. Then people want to develop something new. So they do a second method, these trickling methods. What is the trickling methods they do? This is the same thing. Is a wood barrier. Okay? At the bottom, there is a tray. Okay? And here, there's also a valve for product. Now the product is going here. Now, this oxygen is only going from this meshed window. This oxygen is going to come in from here. Okay? The key thing here is, what's the difference between trickling and orange? You're going to add a lot of shavings. These shavings containing bacteria. So what they really adding? They called beech woods shaving. Now Tim will tell you what are the shavings. Like the birds, you put that on the pans at the floors. Those are shavings. We need to grow the bacteria on the surface. Because all these shavings let the bacteria in a large area. Bacteria survive in extended area. So generate what? A biofilm. Because it's important for the fermentation. So they're on the surface a lot. Then what they do, there is a like some spray here. and they're gonna only drip some of the liquid going down. So when they're dripping, it looks like this, it looks like this. Okay, so they drip the wine on the top, like you're doing the raining, doing a shower, and then you have a shavings there. The shavings has been survived, covered with bacteria in that extended area, have filled the biofilm. So the fermentation is more efficient compared to only this bacteria floating on the surface, because it's a large area to touch the wine. Another thing we also want to mention, this oxygen at the bottom, the temperature usually 75 degrees Celsius. At the top is 29 degrees Celsius. And you know the hot oxygen, usually it's lower density, so they go up. So what happened is these oxygen, I'll use another one, these oxygen most of the time, they will be going up, the oxygen. Okay? So this good circle also let the oxygen more efficiently to attach into the bacteria and the wine. So this process, you generate the products. Only need 3 days, you can generate vinegar. And also, you know there is some waste right here? And these waste usually you can go up again to recycle. Okay? So it's like cut down half the time for fermentation. But be careful, this one also has a challenge, is all these shavings. These shavings, you have to refresh it, and also it's kind of like a waste. So which means you make a vinegar, but at the end of the day, you have to take care of these shavings. And be careful, in the history, lots of people using different products to do the shavings. Some of them even using a comb, These things in the comb surface, they have a niche, they can, more area. You know, every surface will have a niche. That means extended area, but it's not successful. So they tried lots of products. Later on, they find beetroot shaving is the best one. Okay? So this is the second method, the trickling methods. But those two, this is very old. This is only for those small local processors. Now, what the real industry they do? Submerged bioreactor. Okay, they're going to do is those very large tanks. These large tanks is of course made by stainless steel. Stainless steel. Now, what's the major thing here? They add here is added from here, okay, all the way to the top, added inoculant, which means bacteria, and wine. Now, why it is more efficient? There is 2 reasons. So why is dripping going here? With bacteria. What is the major thing? At the center, there is a blade and a fan. This blade and the fan will use an electronic panel. They will do spin. This spin creates a lot of oxygen. Okay, so instead of you using shavings, you're using just floating, you have a fan there, so the oxygen will be more circulated very well. Like this. So this is the key. Let the oxygen circulate much more efficient. And what are the others? On the side, there is a temperature control And this temperature usually is higher, 40 to 42 degrees Celsius. In a little bit higher temperature, the fermentation will be a little bit fast and more efficient. Now, of course, you have this guy comes out. That's going to be another vial. And how short the fermentation can generate? As soon as 1 day or less. That's what the large industries they do about it. Okay? But of course, the cost of these are much more expensive compared to all these older ones. Okay? So this is what I have for the vinegar. And we could be talk about in here, in the slides 21, we mentioned about there is a lots of other vinegar you can make, like malt, wine, apple cider fruits, rice, coconut can. And slides 22nd is a little bit easy because this is we just skip the procedure. This is more complicated. And that bacteria is gluconobacterial oxidants. Okay. Then we talk about orange methods. Orange methods usually 300 to 500 barriers. Then we talk about these use wood barriers. There is bacteria will be attached on the side of the bottle actually. Okay. Now rapid we want to do is that trickling and submerged. So trickling, we have a slide which is at 27, which showed you to use those wood ones. They can be dropping, have the biofilm. And then we have a picture at 28, which showed you how they do it. And an acetator, the bioreactor, is a submerged acetate. By the way, I also want to mention one thing. This is acetic acid. If acetic acid in a salt form, it will become acetone. Okay, what is acetone? And Olivier, you should know this. This is major components of nail remover. And this guy, most of the time coming from Clostridium fermentation. Okay, so sometimes some of the lecture, when they talk about the fermentation, they also mention this acetone because it's very easy. It's acetic acid salt formation, and using for nail removal, they do a lot in the industry. The more efficient way is not going through the process, is using Clostridium, and it's more quickly. But the tricky thing for Clostridium, most of the time, they will be also pathogen, so it's a tricky. Now, another thing I also want to let you know, when we talk about, I forgot to talk about this canned food, if you remember, we have a lot of regulation. Talk about Clostridium, perfringens, those. What's the regulation in West Virginia? pH more less than 4.0, because this is a low acid food. Okay, what is low acid food? If you still remember, what activity around 0.86 and the pH about 4.6. Now West Virginia, the only regulation is pH less than 4.0. As Susie Slider usually to do this, working with Department of Agriculture in the whole state, they do like that. Okay, so just let you know, I forgot about in the Canada. Others I think we already covered. Okay, so that's end up with almost we talk about in this semester for this lecture part. Then one more thing I want to talk next week is antimicrobials, because some will be doing the research using it. So we want to talk about it a little bit. Some of them covered in food chemistry class, lots of them covered in the food microbial class. So we want to give a talk. Then Kim, you will do a presentation on Thursday, talk about feeds, and you and Rebecca will talk about pick some topics the following Tuesday. Is that okay? That's good. Okay, thank you.